Lesson 105, Recognizing and Extending Geometric Sequences. A sequence is just a list of numbers that follows a pattern. An arithmetic sequence, everyone say arithmetic, good, is when we add or subtract the same amount to get to the next number. Now a geometric sequence is when we have a constant ratio. That's when we multiply or divide by the same number each time to get to the next one. So here's an example. We want to know, is this sequence 5, 10, 20, 40 a geometric sequence? So to find out, we want to know, is there a constant ratio? So we take the second number 10 divided by the first, and that is 2. Then we're going to take the third number and divide it by the second, and that's 2. So it looks like we're timesing by 2 each time. 40 divided by 20 is also 2. So yes, it is a geometric sequence, and the rule is 2 times by 2. So you take the number divided by the number before it. So if we chose 20, we divided by the 10, and that is what you are multiplying by. And sometimes it's a fraction or a negative number. Here's one, example 2. We want to know, is this a geometric sequence? 270, then negative 90, 30, negative 10. So if we take the number negative 90 and divide it by 270, that reduces to negative 1/3. And then if we do 30 divided by negative 90, that also reduces to negative 1/3. So I'm going to guess that this is a geometric sequence. And if I divide negative 10 by 30, I get a negative 1/3. So yes, this is a geometric sequence, and the rule is to multiply by negative 1/3. That is called the common ratio. Negative 1/3 is called the common ratio. And up here in example 1, 2 would be the common ratio. So here's another example. We have 3, 4.5, 6 and 75 hundredths, 10 and 125 thousandths. Now the question is, what is the common ratio? So we already know that it is a geometric sequence, and we want to know the common ratio. So we could just take 4.5 or 4.5 and divide by 3. And that's going to be 1.5, and that is the common ratio. In example 4, we're going to be asked to find the next 4 terms of this sequence. So we have 36, 12, 4, 4/3. It looks like we are timesing by 1/3. So our common ratio is 1/3, or we're dividing by 3. So we could just take our 4/3 times it by 1/3. We get 4/9. Then we take 4/9 times it by 1/3. And we get 4/27. So that's the next 2 terms. Then we take 4/27 and times it by 1/3, and we get 4/81. Then we take 4/81 and times it by 1/3, and that's 4 divided by 243. So the next 4 terms are, let's see, we'll put our answer right here. 4/9, 4/27, 4/81, and then 4 divided by 243. That would be the answer. Here's another one where we need to find the next 4 terms. we have 2, negative 10, 50, negative 250. So if we want to find the common ratio, we're going to take negative 10 divided by 2, which is negative 5. So we times negative 250 times a negative 5. And we get 1,250. Then we times that number by a negative 5. That's going to give us a negative 6,250. Then we'll times that by a negative 5. That's going to be a positive 31,250. And then we take 31,250 times a negative 5. It's going to be a negative 156,250. So those are our next 4 terms. Well, we'll just go like that. Circle them this way instead of rewriting them. Now, if we want to find the nth term, now n is whichever term we're trying to find. If we're trying to find the third term, n is 3. So a sub n is what we're looking for, the nth term. We're going to take our first term, a sub 1, that's our first term. We're going to times it by r, which is our common ratio, raised to the n minus 1 power. So here's an example 6. This says find the 12th term. So since we want the 12th term, n equals 12. So we're going to come up here, we're going to say, oh, we need to have our list, don't we? 2, 4, 8, 16. So our common ratio is times by 2, so it's 2. And our first term is a 2. So we're going to plug into this equation. We have a sub 12, so that's the 12th term, is our first term, which is 2. Common ratio is 2 raised to the 12 minus 1, or to the 11th power. So a sub 12 equals 2 times 2 to the 11th power. 2 to the 11th power is 2,048. And when you double that or times it by 2, we get 4,096. And that is the 12th term and the end of our lesson.